Okay, Year 7, welcome back. Happy New Year to this strange world. Some of you probably sit in the classroom, but most of you probably sitting at home. Hopefully you're going to keep up with this work that we're setting while you're not here for at least the next 2 weeks. This lesson today is on distance time graphs. So you will see here now, let's do it now. What I'd like to do is to pause this video and spend the next 10 minutes just seeing how many of these questions you can complete in that time. Some of them are fairly straightforward, some of them are quite challenging. They go back to the work that you did just before the holiday. So if you pause the video now, and now we'll just go through these to see how many you could do. So the equation linking speed, distance and time, one way around to write this is speed equals distance divided by time, but you might have written distance equals speed times time, or time equals distance divided by speed. Any of those would be the correct answer to this question. To calculate the speed of a woman who runs 60 metres in 12 seconds, we look for the distance, 60 metres, the time, 12 seconds, do 60 divided by 12 in your calculator, and you will find that's 5. And don't forget the units, that's 5 metres per second. The speed of a horse that runs 20,000 metres in 1,250 seconds. So the numbers look trickier, you'll probably need a calculator at this point, but you can just do the same equation. So its speed is distance, 20,000 metres, divided by the time, 1,250 seconds. Put that in your calculator, you'll get 16 metres per second. Okay, these are the slightly more challenging ones. So the speed of the horse that runs 2 kilometres in 130 seconds, the trap here is not to do 2 divided by 130, but to turn your kilometres into metres. So 2 kilometres is 2,000 metres. So we do 2,000 divided by 130, which with a little bit of rounding comes to 15.4 metres every second. For the time it takes for a car to drive 50 kilometres at 25 metres per second, now we need to rearrange this equation to get time is distance divided by speed. So if you're going to cover 25 metres every second, how long is it going to take you to do 50,000 metres? So you do the 50,000 divided by 25, it will take you 2,000 seconds. The distance a jogger will run if he jogs at 3 metres per second for 30 minutes. So another trap for you here, 30 minutes. But this is 3 metres per second. So you need to turn your 30 minutes into seconds, 60 seconds in a minute. So 30 times 60 is 1,800. So for 1,800 seconds, every second he's jogging 3 metres. So you do distance equals speed times time, 3 times 1,800, which is 5,400 metres. Okay, these are the very challenging questions. So 2 athletes run a 100-metre race. One runs at 10 metres per second, and the other runs at 9 metres per second. How far does the first one win by? So obviously this athlete is going to win because he can run faster. When does the distance to win by happen? Well, this is when this person crosses the finishing line. So this person is going to take 100 metres divided by 10 metres per second, so 10 seconds to finish the race. In that 10 seconds, the second athlete has run 90 metres, 9 metres per second for 10 seconds. So they're at 90 metres when the first one crosses the finish line. That means that the first one wins by 10 metres. Okay, to convert 20 kilometres per hour into metres per second, so you'll often see miles per hour or kilometres per hour used in everyday life, and sometimes it's useful to be able to convert the units. So 20 kilometres is 20,000 metres. 1 hour is 60 lots of 60 seconds, so 60 minutes, each one of those 60 minutes with 60 seconds. So 20,000 metres per hour is 20 kilometres per hour, but we're not doing per hour, we're doing per second, so we need to divide that by 3,600, so 5.56 metres per second. Okay, that's a pretty hard question there, though. It's even for GCSE, a lot of GCSE students would find that quite hard. So a man runs 2 kilometres at 5 metres per second and then jogs back. Calculate his average speed. This is a classic trick question. You might think he's doing 5 metres per second and 2 metres per second, so the average would be 3.5. But the truth is, he spends a lot less time running at 5 metres per second because he's doing the same distance at each speed, so this time is much less. So it turns out that if you run 2 kilometres at 5 metres per second, 2000 divided by 5 gives you 400 seconds. But if you run 2 kilometres at 2 metres per second, it takes 1000 seconds. So this whole race takes, or this whole jog takes 400 seconds for the first part, but 1000 seconds for the second part. That's 1400 seconds altogether. How far has he run? Well, he's run 4 kilometres. 2 kilometres there, 2 kilometres back. So 4,000 metres in 1,400 seconds gives him a speed, an average speed of 2.9 metres per second. Okay, so I hope you could do the red ones. The amber ones, quite tricky. There's some really hard green ones there. If you've done any of those, you've done a really good job. Okay, so the lesson is the fifth, and it's the fifth. So this is on distance time graphs. We're going to look at how to draw distance time graphs, and we're going to try and use the same equation for speed that we've done to try to work things out from the graph and talk about the slope of the graph and the speed. So here's a little animation to give us the idea. This is a distance time graph. So the key things to notice are we plot distance up the side axis. We always have time on the horizontal axis. So the time is in seconds, so we've got 1, 2, 3, 4, 5, 6 seconds. We've got an even spaces there, and we've got 2, 4, 6, 8, 10 metres up the side, even spaces up this side. And we're going to plot a line graph. We're going to do this for a girl who's walking slowly, then stops, and then walks quickly. So you might want to just again pause the video here for a second and just think, what shape do you think this graph will have? Okay, if she's going to walk slowly, then stop, and then walk quickly. Okay, so if you've had a little quick think about that, here's the animation to show you. This runs at real speed, so I'll just let it run through. So here she comes, she walks. In my case, she's walked for 3 seconds. Now she's stopped walking. Look what happens to the line. And now she's walking again, and hopefully you can tell that she's walking faster. Here are the 3 sections of the graph. So this is where she's walking slowly. She's walked a distance of 6 metres in a time of 3 seconds. So it's fairly slow, and the slope of the graph is fairly shallow. If she'd walked even slower, if she'd only walked 4 metres for example, then she'd only have got to here. She'd only walked 2 metres in 3 seconds, she'd be there. Okay, so the shallower the slope of the graph, the slower she's walking. Here is the point here where she's stopped. So for these 3 seconds here, she's stopped. And you might think, oh, she's 6 metres, she's gone 6 metres, but she hasn't gone 6 metres in this time. She was 6 metres away from the start, and she's still 6 metres away from the start, so she's in the same place. Here's the last part of the graph where she's walked much more quickly. So here she's walked from 6 metres to 22 metres, so 16 metres in 1, 2, 3, 4 seconds. You can count the seconds if you like, or you can do 10, take away 6 to get the 4 seconds that she's walked for there. Okay, so if we just watch that again, here she goes. She walked 6 metres in 3 seconds, stood still for 3 seconds, and walked 16 metres in 4 seconds. I'm hoping you can already think that that means you can work out the speeds in those times. So if she did 6 metres in 3 seconds, she was doing 2 metres every second. See from the graph here, 2 metres in the first second, another 2 metres in the second, another 2 metres in the third second. Then she didn't move at all. She stayed 6 metres away from the start for these 3 seconds. And then in this second, she's gone from 6 to 10, so she's walking at 4 metres every second after that. Okay, we can do that a bit more formally so you can see. So here's the first part of the graph. The time that this took is from 0 to 3 seconds. So in the first 3 seconds, the total distance that she's away from the start is 6 seconds. So, 6 meters. So she's 6 meters away from the start. She spent 3 seconds in that section. 1, 2, 3 seconds in that section. In that time, she's walked those 6 meters. So she was 0 away at the start, 6 away at the end. So she walked 6 meters, which means the speed in that section is the distance in the section 6 divided by the time in the section 3. 6 divided by 3, 2 meters per second. Here's our second section up to 6 seconds, and the total distance away at the end is still 6 meters. The time that she spent in this section is 3 seconds, but the distance that she moved in this section, well, she was 6 away at the start and she's still 6 away, so 0 meters. So the speed that she's moved at in that section is 0 meters per second, which is another way of saying she wasn't moving. Here's the last section. So by the end of this time she was 22 meters away from the start, but she was already 6 meters away at the start, so the distance that she's moved in that section is 16 meters. The time that took was 1, 2, 3, 4 seconds. As I said, you could do 10 minus 6. So 4 seconds. So how fast was she moving? 16 meters per second. 16 meters in 4 seconds is a speed of 4 meters per second. Okay, if you need to just pause the video there and have a little check that you've understood all that. That's quite a lot to get your head around in that little section, so have a little pause there if you need to. Okay, and if you think you've got that, here's another graph. This is a boy running. So have a look at this graph, see what you can tell. Where was the boy moving fastest? Is there anywhere where he wasn't moving? Could you actually calculate the speed he was running at the different sections of the graph? Okay, I'm going to just ask you again to just pause the video here and just see if you could work those things out for yourself. Okay, so if you've done that, here's the first section here. It's taken 1, 2, 3 seconds. Got to be a little bit clever reading off the graph here. 15 meters. So in the first section, he's run 15 meters in 3 seconds. So 3 seconds to do 15 meters. So the speed is 5 meters per second. Just have a think, is this going to be quicker or slower? So I'm hoping from this you can see the slope of the graph is less, so the speed is slower. In the next 1, 2, 3, 4, 5 seconds, he's gone from 15 meters to 30 meters. So this time it's taken 5 seconds to do 15 meters. So now the speed is running at is 3 meters per second. Here's the last section. So the last 2 seconds, 30 meters away, but he's 30 meters away at the start and he's still 30 meters away at the end. So in the last 2 seconds he hasn't moved at all, so the speed is 0 meters per second. Okay, again, pause that if you need to and have a little look at it and think about it, and we'll just try one more. Okay, so here's the last one from a car journey. So a little bit more to this one, so again, pause it, have a look at this graph, see if you can work out the answers to this motion of this graph. Okay, so here we go. In the first 30 seconds, this car has driven 450 meters. So the speed is the distance, 450 meters, divided by the time, 30 seconds. 450 divided by 30 is 15 meters per second. from 30 seconds to 60 seconds, so that's another 30 seconds. It's gone from 450 metres away to 1,500 metres away. So again, the numbers are a bit tricky. Hopefully you can see to check this, we're definitely going to get a higher answer than 15 because the graph has got steeper. Okay, so 30 seconds, we've gone 1,050 metres. So we do speed equals distance divided by time. 1,050 divided by 30 gives you 35 metres per second at this time. See, 35 metres per second is faster than 15. The line has got steeper. So in the next 20 seconds, the car hasn't travelled any distance at all. So if you travel 0 metres in 20 seconds, your speed is 0. This is the first one we've got where the graph's going the other way. So we can still work out the speed in the same way. This is 10, 20, 30, 40, 50 seconds. We've gone from 1,500 metres to 0 metres, so the distance we've travelled is 1,500 metres. So 50 seconds to do 1,500 metres gives us the speed is distance divided by time. 1,500 divided by 50 gives you 30 metres per second. What you can say is that they're going back towards where they started, so at the end of this journey the car has ended up back where it started again. So it's travelling at 30 metres per second but in the opposite direction. Okay, at this point you should have 4 sheets attached in Teams, so you can pick from which of these 4 sheets you are happy with. If you think you've followed all that and you totally got it and you thought there was no worries there at all, then go for mastering. If you think, oh, I think I've pretty much got that, but maybe I'm not too confident starting established. If you're thinking, yeah, that was okay, I think I've pretty much got it, have a go at expected. If you're thinking, well, I really need to slow down a bit there and think about that, there is an emerging sheet. If you start doing one of these sheets and you think, oh no, maybe I've chosen one that's a bit too easy or a bit too hard, right, then feel free to change. I'm hoping that you can, if you're on a computer rather than on your phone, then you can actually submit this sheet back to us filled in. Some of it will be tricky because there are graphs to draw, but you can fill the tables in and answer the questions on the worksheet and then save it back into Teams as your version of that worksheet. But this should take you probably about 20 minutes, so I'm going to ask you to pause the video here, spend the next 20 minutes or so having a go at that sheet, and then there are some more video which will go through the answers for you. Okay, so here's the first sheet if you did the emerging ones. If you didn't do these, it might be worth your while just checking anyway. So the first thing it asks you to do is to plot the graph. So these are the different points on the times on the graph, and these are the distances that we've got to. So within the restrictions of PowerPoint, it's quite hard for me to plot the graph exactly. Here's the first section. We started at 0, 0. After 50 seconds, we've done 100 metres. So 50 seconds, 100 metres. Okay, in the next 30 seconds we didn't go anywhere at all, we were still 100 metres away after 80 seconds, so that's that section. After 220 seconds we were 1,500 metres away, so we've got to find 220, which is here. So 220 and 1,500, okay, so we're up to there. And then by the end, at 260 seconds, we'd gone 1,800 metres. Okay, and you need to try to understand the story. So Jen gets to school by walking to the bus stop. She waits for the bus drops her off on Clarence Road, and she's a bit late, so she runs down the gully. So how long did it take to walk to the bus stop? That's this bit of the graph here. It's taken her 50 seconds to walk to the bus stop. How far away was the bus stop from her house? Well, if you look at the table, she's walked 100 metres in that time. So it's 100 metres from her house to the bus stop. How long did she wait at the bus stop? So that's this section here where she's not moving. You can see this goes from 50 seconds to 80 seconds. So that's taken her 30 seconds. How long was she on the bus for? She's going from here, which is 80 to 220. So she spent 140 seconds on the bus, which is not long, but it makes my graph work. So perhaps she could have just walked, really. How far did the bus go? Well, the bus has picked her up here 100 metres from her house, and it's dropped her off 1,500 metres from her house. So she must have travelled 1,400 metres on the bus. How long did it take to run to the school from Clarence Road? So 220 seconds she got off the bus, 260 seconds she's got to school, so it's taken 40 seconds for her to run to school. How far did she run? 1,500 up to 1,800 metres from her house, which means she's done the last 300 metres running down to school. Okay, question 1 and question 2 will show you how fast Jen walked. So she walked 100 metres in 50 seconds. That means she was walking at 2 metres per second. How fast she ran and how fast the bus moved. So the running bit is the last bit. So she's run 300 metres in 40 seconds. So that's 7.5 metres per second. And how fast the bus moved? Well, the bus did 1,400 metres in 140 seconds. So the bus moved, I haven't got that answer on there for you, but the bus did 10 metres per second. Okay, here's the expected one. So the line's drawn there for you with quite a few sections on it. But you can complete the table here. So the total distance from the start at the end of section 1, here we go, 50 seconds, 100 metres. At the end of this, 90 seconds, we're still 100 metres away from the start. In section 3, we're now 800 metres away from the start, and so on. You can check those answers against your sheet. The time in each section, okay, then the first one here is 50 seconds. The next one's the next 40 seconds, and then another 50 seconds, and so on. So hopefully you got those. And the distance travelled in the section, we're looking from how far is it from the last one. So in the first one she's done 100 metres, but the second one we've gone from 100, we're still at 100, so she's done no metres at all. And so on. Sorry, I beg your pardon. The first one's a mistake there. That should say 100 there at the start, but I think the rest of them are right. That first one should be 100. Okay, which sections was she not moving? So what we're looking for is the horizontal lines. If the line is horizontal, that means she's staying the same distance from the start, which means she's not moving. So hopefully you can see that 2 and 4 are the parts of the journey where she's not moving. The slowest section, we're looking for the shallowest line. Okay, so the shallowest line there is section 1. And the fastest bit, we're looking for the steepest sections. Okay, so the steepest sections are, well, I think it's probably just 3 is the actual steepest one, but 5 is nearly as steep. I would have to check that to be sure. We'll check that in a minute because we'll work out the speeds. Okay, so complete the story of Jen's journey to school. So Jen left home and walked to the bus stop, and she walked for, here we go, here's her walking to the bus stop. That's taken her 50 seconds. And she travelled a distance of 100 metres. She waited for the bus. Okay, here we are, this is section 2, and she waited for the bus for 40 seconds. The bus moved off. How long did it go for? It's from there to there, so this is 90 seconds to 140 seconds, so 50 seconds. Okay, it then stopped again. It's a different stop. Okay, we are 800 metres from home, but 700 metres from the we're already 100 metres from the first stop, so 700 metres from where she got on. It then stopped again. It stopped for 20 seconds. It then moved off, and it went for another 50 seconds, and it travelled another 700 metres. Okay, so actually we can see that the two sections are both 700 metres in 50 seconds, so 3 and 5 are the same You can put a ruler and see if those two lines are parallel, the same speed. Finally, Jen jumped off the bus. From here to here she's run. So she's run from 210 seconds to 260 seconds. So she's run for 50 seconds. And how far has she run? We've gone from 1,500 metres to 1,700 metres away. So she's run the last 200 metres to school. Okay, we can add the last section here with the speeds. So for each section we can look at the distance in the section, okay, which is this one divided by this one. See, that first one should be 100, so that would be 2. 0 divided by 40, 700 divided by 50 is 14, and so on. Okay, so just check those. Here's the established one. So again, the same sort of story. So the graph shows Jen's journey to school. Here she goes. Just a little few subtle extra details in here. So how fast does she walk to the bus stop? So now you've got a bit less help. You've got to work this out for yourself. So this is her walking to the bus stop. Okay, it's taken her 50 seconds to get there, and it's 100 metres. So 100 divided by 50, the distance 100 metres, and the time of 50 seconds gives you 2 metres per second. How long does she wait? So that's the flat part of the graph here where it's horizontal. So that's 20 seconds, from 50 seconds to 70 seconds, 20 seconds. Okay, but this graph shows you something that we haven't really mentioned yet, because so far we've pretended that the bus pulls away and it's just instantly going at its maximum speed. But you'll notice here, this line is curving, because this is what happens in the real world. The bus has to accelerate, and as it accelerates, this line gets steeper and steeper and steeper, because remember, the steeper the line is, the faster you're going. So to get the maximum speed of the bus, we just need to find the steepest part. So the steepest part of the graph, which is this part here, you might have drawn a slightly different part, but you could get the same answer even if you did say this part of the graph. Right, this has gone from 140 seconds up to 190 seconds. So this is 50 seconds, and in that time she's gone from 700 metres away to 1,400 metres away. So she's travelled 700 metres in 50 seconds. That is 14 metres per second. How fast has she run down the gully? So again, that's this part of the graph, and she has done 200 metres, so 2 squares on this scale is 200 metres in 50 seconds. So she's run at 4 metres per second. Okay, and explain how the graph shows that the bus takes time to speed up and slow down. It is these curved lines, this bit here and this bit here, is where the speed is changing and the line is curved. Okay, we could work out the average speed of the bus by going all the way from there to there, but that wouldn't be the maximum speed of the bus, that would be its average speed. Okay, and here's the super hard one. So the other sort of graph that you do when you get to GCSE is speed time graphs, and people often get confused between these two graphs. So let's look at the top bit first. So just turn this passage into data. So a man runs at 8 metres per second for 10 seconds, then walks 20 metres at 2 metres per second, then stops for 5 seconds, then runs again at 5 metres per second for 20 seconds, and then jogs 15 metres at 4 metres per second. So lots of parts to this to complete this. So section 1 is where he's running. He runs for 10 seconds, and he runs at 8 metres per second. So in that time he will run 80 metres. The time for that section will be the 10 seconds. The distance in that section will be the 80 metres, and the speed it's told us is 8 metres per second. Okay, I'll fill all those in so you can see them. So here's and then what did he do? Well, he walks the next 20 metres at 2 metres per second. So this is another 20 metres, so he's now gone 100 metres altogether. In that section he's done 20 metres. It took him 10 seconds to do that. 20 metres at 2 metres per second is 10 seconds, which means the total time is now 20 seconds, and the speed in that section, as it says, is 2 metres per second. Okay, then he stops for 5 seconds, so we've done 25 seconds altogether now. He hasn't got any further, so still 100 metres from the start. He spent 5 seconds, stopped, didn't go any further, so the speed was 0. Then he runs at 5 metres per second for 20 seconds, so another 20 seconds on the time. How far will he go? Well, he's doing 5 metres per second for 20 seconds, so he'll go another 100 metres, so he's 200 metres away now from where he started. The time for that section, 20 seconds in that section. The distance from the section, 5 metres per second for 20 seconds is 100 metres, and he was running at 5 metres per second. Then he jogs at 15 seconds at 4 metres per second. Okay, so this is another 15 seconds, so we've gone from 45 to 60 seconds. He will have gone 60 metres, so he's now 260 metres away from the start. 15 seconds for that section. He's gone 60 metres, and that means if he does, he's doing 4 metres per second, because it's told you 4 metres per second. You can then take all that data, and we've got the total time and the total distance, so these numbers are what plot onto our graph, and the graph should look like this. So 10 seconds to do 80 metres, then another 10 seconds to do 20 metres, then a stationary part, then the part where he's running, and then the part where he's jogging. Okay, there is a join in that. If you see, these are two slightly different speeds, but he's only gone from 5 metres per second to 4 metres per second. Okay, so that's obviously very challenging to get your head around all that data. If you had a go at this sheet, you've done really well. And then we can look at a speed time graph, which actually, strangely enough, and this turns out to be a bit more straightforward. So for the first 10 seconds, he was doing 8 metres per second. So here we go. And this is horizontal, but this is where you must not get confused. This is a speed time graph, and on a speed time graph, if it's horizontal, that doesn't mean he's stationary, that just means the speed is staying the same. So 8 metres a second, and then 2 metres per second, and then 0 metres per second, and then 5 metres per second, for 20 seconds here altogether, 5, 10, 15, 20 seconds, and then 4 metres per second for the last part. So here are two graphs, just drawing those up. So here are two graphs which actually show the same journey, even though they look totally different. So you can see it's very important that you know if you're doing a distance time graph or a speed time graph. The slope of a distance time graph tells you how fast they're going, and the height of a speed time graph. So this is the fastest part on this distance time graph because it's the steepest line, but this is the fastest speed on the speed time graph because the line is highest. Okay, so the connection is that the slope of this line tells you the height on this graph.